All right, so we're going to identify proportional relationships, which means we're going to determine whether two quantities are in proportional relationship. I can determine whether the ratios form a proportion. I can explain how to determine whether quantities are proportional, and I can distinguish between proportional and non-proportional situations. So here we go. A proportion is an equation. That's the first part. And it's an equation stating that stating that the values of two ratios are equivalent. So if we look, 2 to 3 and 4 to 6 are equivalent ratios. And so in a proportion, we're just saying that 2/3 equals 4/6, which is true. So to tell whether the ratios form a proportion, we're going to write them out as fractions, 6/4 and 8/12. And we're going to look at this and we're going to go, hey, does 6/4 equal 8/12? Now, there's a lot that could be said here, and there's lots of different ways we can do this. We could simplify both fractions. We could stop and analyze both fractions. For instance, 6/4 is improper, whereas 8/12 is proper, so therefore they can't be the same. They can't be equivalent. But in case you can't see that, I'm going to I'll show it this way. I'll simplify these. So dividing these both by 2, we'd get 3/2. Dividing these both by 4, we'd get 2/3. And hopefully that doesn't take too much for you to realize that 3/2 is not the same as 2/3, especially because 3/2 is bigger. So these are not proportional. Down here, though, we've got 10 to 40 equals 2.5/10. So this one's a little bit trickier. Couple different ways you can go about doing this. You could stop and see, okay, well, 10, if I turn 10 into a 40 by multiplying by 4, I might see something. If I turned a 2.5 into a 10, I might see something. If I divided 40 by 4 to get 10, I might see something. There's lots of different ways we could do this. Or we could just simplify the fractions. We could simplify this down to 1/4 and then see what happens with this. You just have to pick a method. You just have to do something. The problem is that there's too many things to choose to do and make everyone happy. I can't do that, and I can't tell you that there's one right way of doing it. So I think that the best thing that I could do is simplify the fractions. So I'm going to simplify 10/40 down to 1/4. And 2.5/10, if I multiply by 10, that's going to be 25. And multiply this by 10, and that's going to be 100. So I'm actually looking at 25/100, but 25 goes into both of these, and so I'm left with 1/4 again. So these are proportional. Now, that's kind of sloppy, so there's a better way of doing it, and it's through cross products. So the idea of in the proportion A/B equals C/D, the products of A times D, we cross these, and B times C, we cross these, are called cross products. Do not start talking to me about butterflies, because that ain't this. These are cross products. The cross products of a proportional the cross products of a proportion are equal. And we see that 2/3 and 4/6, which we've talked about before. 2 times 6 is 12, and then 3 times 4 is 12. So the easy way of dealing with this, instead of doing what we did before, we can just check our cross products. 6/9 equals 12/18. We multiply. 6 times 18, 48 on the bottom, carry the 4, that's 108, and then 9 times 12. And that's also 108. So these are proportional. Over here, 2/3 equals 4/5. cross products. That's 2 times 5 equals 3 times 4, and 2 times 5 is 10, and 3 times 4 is 12, and those are not equal, so this is a no. And I think that's an easier way to do things than stumbling blindly through this. All right, so tell whether x and y are proportional. So what we have to do is, all we're going to do is we're going to find the ratio of each of these. Basically, we're going to find the unit rate of each of these. We should, you can either choose to do x over y, or you could do y over x. You just have to be consistent. And I'm looking through this and I'm going, well, if I do y over x, I get this one right here, and that's just 6 to 1. And I like that. So let's go ahead and do y over x. So 3 divided by 1/2 is keep, change, flip. So 3 times 2 over 1 equals 6 over 1. So far so good. We've got two, these two, if these two were the only things in the table, this would be proportional. The next one, we're doing 9 over 3 over 2. So keep, change, flip. We've got 9 times 2 over 3. And so that would be 9 divided by 3 is 3, times 2 is 6. So we have 6 over 1 again. So these 3 terms here would all be a proportional. And then we've got the last one of 12 divided by 2, and that's 6 over 1. So since all of them create the same ratio of 6 over 1, this whole table is proportional. Last problem, this one's kind of a weird one. You swim for 16 minutes and complete 20 laps. You swam your first 4 laps in 2.4 minutes. How long does it take you to swim 10 laps? So let's talk about things in laps per minute. And as we do that, our first 4 laps were swam in 2.4 minutes. And we're going to find the unit rate of that. So I'm grabbing my calculator. Four divided by 2.4, that gives me 1.6 repeating. Then, if I do 20 divided by 16, that gives me 1.25. So, swimming 10 laps is not proportional. I can see that clearly by this. So what I'm going to do instead is I want to figure out 10 laps. So I know that 4 and 2.4, and these are laps. So I'm going to do an approximation. And I'm going to turn a 4 into a 10. So to do that, 10 divided by 4 is 2.5. And then 2.5 times 2.4. That's 6. So if we kept up the pace of 4 laps in 2.4 minutes, all the way through 10 laps, we'd be at 6 minutes. But we know we didn't keep that pace because we have lap of 20 and minutes of 16. And we want 10 laps here. Now, if you think this through, to go from 20 to 10, you can divide by 2. So I'm going to divide by 2 to go this way. And that's going to give me 8. So I know that my answer is somewhere between 6 and 8 minutes. So we're just going to say that about 7 minutes. That's all there is to it. And I know that some of you might feel like that's gross and disgusting because it's not a specific answer, but that's the way math goes sometimes. All right. well, that ends our notes.